Okay, so good afternoon, guys. So, just feeding back from yesterday afternoon's lessons, I was told by some of you that you felt the lesson was just a little bit too condensed, so we just need to spread them out. So that's what we're going to do. So this first part of the lesson is just going to be about differentiating the expressions, and then just finding the gradient when x equals 2. Okay, just to get you into the habit of differentiating and then just finding the gradient of the differential at a specific point. So going for the first one, I have x to the power of 4. So the gradient, or the first differential, would be, well, if I compare this to this, a equals 1, so just going to have 1 there because 1 stays. N equals 4, so I need to bring that 4 down. X remains as it is, and then I have to take away 1 from the power. So 4 take away 1 equals 3. This would then be 4x cubed. Okay, and then I would say dy dx when x equals 2, which is the third column just here. So dy dx when x equals 2. So instead of x, I'm just going to put 2. So it will be 4 times 2 squared, which is 4 times 4, which is 16. Okay. Next one, we just have a different color. Next one, I have y equals x squared take away 5. So dy dx. Okay, same as up here, you just do it in 2 separate terms. So even if it's 2 separate terms, all I need to do is make sure I do it individually for each of them. So for this one, which is my x squared, my a is equal to 1, so that would be 1. The power comes down, so the power is 2, and then x to the power of 2, so take that, take the x, that 2, take away 1, so it would be x to the power of 1. So that would be this term. Okay, and then the 5, anything that is a constant just automatically gets written off. So that just doesn't exist. So you could say plus 0 if you really want, but it just becomes 0 because the gradient when you have a horizontal line is 0. So it's essentially just not going to count. So if I simplify that, oops, that would be 2x. Okay, and lastly, just to find dy dx when x equals 2, that would just be, because you may not be able to see it down there, oh no, you will. So I've got 2 times 2, which is 4. That's your answer. Okay, if you do want to pause, I'll go through all of these examples that I have just over here. But if you do want to kind of pause and try it yourself first, you can always do that, and then you've still got those as well. Okay, so this is just to take you through all of these so you can see different types of examples. Okay, so y equals 3x take away 9, dy dx. Okay, so a equals 3, so I'm going to put 3 there. The power is 1, so it's just 1 coming down, and then x to the power of, so 1 take away 1 is 0. Okay, so that's this one. The 9, I've already told you, if it's a constant, it just equals 0. So when I simplify this, x to the power of 0 is 1, so 3 times 1 is just 3. That is your answer, okay? And then last but not least, we just say dy dx when x equals 2, because that is my third column just here. It's just 3. Okay? Next one. I have y equals 10x squared. So dy dx. So a equals 10, so this a is going to stay. And then I need to bring the power down, so that n is brought down there, so that power would be 2 times x. Instead of to the power of 2, it's just to the power of 1 because you're dropping a power. And then I just need to simplify that, so 2 times 10 is 20x, okay? And then it says dy dx when x equals 2. So that will be 20 times 2, which is 40. Okay. That one. Okay, so next one. I've got x plus 3, x minus 6. Okay, I don't have separate terms, so the first thing I need to do is just expand the brackets. So if I expand these brackets, I should have x squared, take away 3x, take away 18. Okay, so dy dx. So you should be used to this by now. You're just dropping down at that 2. So a equals 1, 2 comes down, 1 times 2 is 2. X to the power of 1, because x squared will then become x. Okay, this one will just become 3, and then obviously a constant is 0. So then I say, oops, dy dx when x equals 2, I've then got 2 times 2, take away 3, which is 4, take away 3, which is 1. Okay, next one I have y equals x squared plus x cubed all over x. Okay, so the first thing, I don't like the way it is right now because I do need to separate the terms, but it's, if you're looking at this fraction, it's quite easy to simplify. So even if I just factorize this, this would then be x plus x squared all over x, and then I can cancel them out. So this actually becomes x plus x squared. I've now got 2 individual terms that I can factorize. Sorry, not factorize, differentiate. So dy dx, so x just becomes 1, and x squared becomes 2x. All I'm literally doing is just following this rule that I've been given. Okay, and then I would say dy over dx when x equals 2. I am then having 1 plus 2 times 2, which is 1 plus 4, which is 5. Okay, hopefully that should be relatively easy. All you have to do for differentiation, when you start getting into the pattern of it, it's actually really, really easy to do. So last but not least, we have y equals x open bracket x to the power of 5, take away 7x. Okay, still not separate terms, so just like we did with the brackets just there, I do need to expand the brackets out, so I've got separate terms, so it'll be x to the power of 6, take away 7x squared. Okay, and now I just need to differentiate that. So I don't have a number in front, so that's just 1. Drop the power down, so you got 6x, and then that would be 5, because 6 take away 1 is 5. Okay, for this one, the power will need to drop down, so I've got 7 times 2, and then that x will just become to the power of 1. So this will be 6x to the power of 5, take away 14x. Okay, and then just putting dy dx when x equals 2. So that would be 6 times x to the power of 5, take away 14 times 2. Fun times. Okay, so 8, 16, 32, so that will be 6 times 32, take away 14 times 2. And because I'm not bothered doing that by myself, this will be 164. Okay, hopefully that should have made sense. So you've got a fair bit of time. I have put a worksheet onto Google Classroom. I do expect you to go through a fair few. I do expect a submission in, and when I expect a submission, I do expect you to show some photographic evidence or some sort of evidence to show what actual work you've done. If you do just press submit, I will be returning it. Okay, if you press submit and all you've done is give me a list of answers, I will be returning it. You are year 10, you are so very close to your GCSEs. especially those people doing it next year, you need to ensure that you are keeping your standards high. So can you please make sure you actually do your work properly? I was not best pleased when I'm seeing a couple of you just handing in just answers. I always give you guys the answers, so if I just wanted the answers, I'd be perfectly happy just coming up with those answers myself. I need to see what process you guys are going through, so can you please ensure you do so? Okay, so I'm going to let you go and make sure you get through those questions. Obviously, you can use this to help you out if you so wish, but just remember that is the only rule you need to remember, especially at IGCSE. Don't need to worry about it getting more complex than that.